Tech Trends is an original podcast series that dives into topics like quantum computing, 5G, and design thinking. Our conversations touch on how tech can transform the way businesses deliver for their customers, clients, and communities. For more information, visit jpmorgan.com/technology.
This is MIT Technology Review.
All right, so I'm at an airport just outside New York City, and just looking at the departures board here, seeing all these flights going different places, it makes me think about how we decide how much something should cost, like a ticket for one of these flights. Because where the plane is going is just part of a puzzle. The price of airfare is highly personalized. It includes massive amounts of consumer data. The prices also change in real time based on things like our booking patterns, competitor prices, even the weather.
But it wasn't always that way. There was a time we could rely on the notion that what you see is what you get. These days, prices are decided by algorithms. It's called dynamic pricing, which prices things according to current market conditions in order to increase profits. And it's not just airlines that use this technique.
A practice started by the airlines, dynamic pricing has now been adopted by retailers thanks to some new technology.
And it's becoming more and more common thanks to computer algorithms. You'll find it with Disney World tickets, hotel rooms, Major League Baseball seats, and now Amazon.
E-commerce propelled these algorithms into an everyday occurrence. But what does that mean for consumers?
Amazon changes prices 2 million times a day. So what is a stable price for any of us, and how will we actually know that we're paying different prices? I think that's going to be a key question going forward.
I'm Jennifer Strong. In this episode, what happens when a machine determines the price you pay?
Let's go.
In Machines We Trust.
I'm listening.
A podcast about the automation of everything.
You have reached your destination.
When gunfire rang out last night, people were looking for any way out. Tonight, some are saying safety went to the highest bidder.
It was the middle of the evening commute, last January, when there was a shooting in downtown Seattle.
Rideshare companies are under fire tonight for raising prices while people were trying to flee the gunfire. Some riders say they were gouged.
The bus that I would normally take would go down the street that the shooting happened on. So all of the buses that were going down that street, they all stopped. They didn't get rerouted or anything. They just stopped.
Lisa Wilkins works in tech, and her office is less than a block from where that shooting happened.
I just decided I'll grab an Uber or Lyft and, just take it home or take it back to my car, which is at a park and ride, which was about 17 miles away. And then when I opened the app, I then saw it was like $100 or something to get there, when normally it would have been maybe $30.
When demand is high, the price of a ride with Lyft or Uber automatically gets more expensive. In emergencies, companies cap those prices once it's clear what's going on, and in this case, offered to reimburse riders who paid higher fares. But even though Lisa Wilkins' job is to design apps with an eye on user experience, she says it still took a moment to realize what was happening to her was because of a pricing algorithm.
At first, I was really angry because you want to take it personally, like they're intentionally doing this. This is a shooting and they're taking advantage of it. And then when I kind of was talking to another coworker about it, we were still upset that it was going to cost so much to get anywhere. But we realized this is price surging. This is a bot basically saying what the prices are going to be. And being a UX designer, I understand there's a lot of edge cases that you might not plan for that happen in your product.
And this can have some unintended results.
There was a book about fly genetics on Amazon there were two competing algorithms that just kept looking at each other and increased the price a little bit. And the other one would increase the price a little bit on top of that. And they just kept going back and forth unchecked for, many days. And it ended up with the price of this book being like $1.2 million, right? My name is Gabe Smith, and I'm the chief evangelist for Pricefx. And I have about 14 years of experience in price optimization and management.
He uses AI and other tools to help companies decide what something should cost. He also thinks about how to avoid those outliers, like that $1 million book about bugs.
So in the 80s really is when the computing power and the data availability got to the point where these techniques could start being leveraged. And really, it appeared first in the airline industries and then followed on in the other travel and leisure industries, such as rental cars and hotels.
Dynamic pricing can help companies know what to charge for products that expire or are limited in supply. Like when a plane takes off, there's no changing how many of those seats are filled. So, to drive the most revenue, airlines need to sell the greatest number of seats for the highest possible price. And to learn what that price is, they need to understand the nuances of passenger behavior and market demand.
So that was really the first use of pricing optimization and artificial intelligence to drive pricing into a market. And since then, it's really expanded in use across many different industries. We have a company, for example, that does dynamic pricing for their ski tickets based on the upcoming events, weather conditions, snow conditions. But we also have other customers that are selling electronics, chemicals. We have industrial manufacturing companies, distribution companies. Really, these techniques are gaining adoption in a wide variety of industries.
The key to making all of this work is a rich data set on consumers and what drives their willingness to pay. The more data, the more targeted prices can be for individuals.
How they behave, what product that you're offering, things like what is the nature of the transaction or the quote that you're doing. All those can be factored in to your pricing optimization algorithms and influence what you're going to offer. So if you have data like that, it can be actually fairly straightforward to be able to implement pricing optimization. So we have customers where we've implemented things in as little as a couple months.
And he says these systems are getting better at managing complexity and balancing competing goals.
So maybe I want to make sure that I'm always positioned in a certain way versus my competition, right? Or maybe I want to say, hey, I never want to increase pricing by more than 5% on anyone. Am I trying to maximize revenue? Am I trying to maximize profit? Am I trying to maximize volume throughput? I could balance between those. So what happens in organizations, there's competing objectives a lot of times. And so you can be guiding not only, okay, what's my list price, but what's the negotiated price or a promotion based on a customer product combination.
These constraints are important because left unbound, pricing algorithms can simply prioritize higher prices. Another issue, making sure those prices don't reinforce systemic bias. But this isn't so straightforward.
It could be that, you don't see one of those things explicitly, but they could be just beneath the surface in another attribute that you're using. So if you're using a zip code or you're using the demographics in terms of the income levels, that there might be systemic bias that's in that data. So you really need to be thoughtful about how you build these things out and make sure that you're doing the right thing from an ethics perspective. And I think part of the acceptance is, do I feel like as a consumer I'm getting a good deal or a better deal in some cases as a result of this, or is it always to the provider's benefit?
We know that big tech uses these individualized pricing algorithms widely, and we don't necessarily understand what is going on behind these systems or algorithms because they are black boxes. We only see the outcomes on an individual basis, basically the price we receive, and we don't really have methods or data sets to systematically study price discrimination algorithms. I am Aylin Caliskan. I'm currently an assistant professor at the University of Washington, and my research focuses on machine learning and artificial intelligence bias.
A couple of years ago, the city of Chicago mandated that companies like Uber and Lyft release fare data to the public. This gave researchers access to millions of anonymized trips throughout the city. She compared prices against the demographics of the neighborhood, and what she found surprised her.
Our results show that neighborhoods that have younger residents or highly educated residents were paying significantly higher fare prices, and neighborhoods that have higher non-white residents as well as impoverished neighborhoods were also paying higher fair prices that were determined by these price discrimination algorithms.
Her team wants to know why this happens, but that's hard without details about supply and demand that aren't made public. Researchers are only able to get a subset of this data.
Are residents in disadvantaged neighborhoods paying higher fair pricing because of the characteristics of their neighborhoods, or does supply of drivers have an impact on fair pricing in these neighborhoods where demand seems relatively low? But if supply is even lower, accordingly, relative demand would look higher, which might be increasing fair pricing. And the more transparency, the better methods we can develop to study the disparate impact of these algorithms or their dynamics, how they are learning from neighborhood transportation patterns and traffic patterns.
Which brings up another thorny issue. There aren't really rules about this.
We need more policy and regulation so that we can get access to this data set and keep studying these and understand how these might be impacting smart city planning as well as resource allocation. Because if such data sets are used, for example, in driverless cars or resource allocation in smart cities, these biases might end up being perpetuated or potentially amplified in the future, causing all kinds of unexpected side effects that we would need to deal with in the future.
After the break, we find out what regulation might look like, and we learn how these algorithms might work in a grocery store. But first, I want to tell you about an event called CyberSecure. It's Tech Review's cybersecurity conference, and I'll be there with my colleagues talking about ransomware and other important issues. You can learn more at cybersecuremit.com. We'll be right back after this.
Tech Trends is an original podcast series that dives into topics like quantum computing, 5G, and design thinking. Our conversations touch on how tech can transform the way businesses deliver for their customers, clients, and communities.
The real power of design thinking from a business perspective is really getting to know your clients, understanding what their needs are, and finding the right problem to solve for your clients.
Employees really like to give back in their day job. And this isn't just the most junior employees or your millennial generation, it's everybody.
For more information, visit jpmorgan.com/technology.
Pricing algorithms can also help consumers by personalizing products and recommendations or providing insights to companies that help them design better products and services. But these systems also present new challenges for those who regulate competition. Congress passed the first antitrust law over a century ago, but it wasn't until 2015 that the government prosecuted its first antitrust case specifically targeting e-commerce. In that case, a man pled guilty in conspiring to illegally fix the prices of posters he sold on Amazon with other sellers, using an algorithm designed to coordinate price changes.
The pricing algorithm would look around for the best or the lowest price of competing sellers, that is, competitors to those two online sellers, and then the two online sellers would set a slightly lower common price. So the two sellers were still competing against other firms in the market, but just weren't competing against each other. So instead of coordinating on a common price, they coordinated on a common pricing algorithm, and that had the same effect of reducing competition. I'm Joe Harrington. I'm professor of business economics and public policy at the Wharton School, the University of Pennsylvania. My research is in the area of collusion and cartels.
The case involving the Amazon poster sellers is something that's pretty close to traditional collusion, where otherwise competing businesses coordinate prices via direct, human-to-human communication. But there's growing research that pricing algorithms themselves could learn to form a kind of digital cartel of their own, and collude to raise prices without any human involvement.
Now let's think about a manager deciding that they're going to delegate the pricing decision to a self-learning algorithm. That self-learning algorithm is going to experiment with different pricing algorithms or pricing rules in the hope of finding ones that are more profitable. So they do end up with more profitable pricing rules. And the reason why they're more profitable is because of the fact that the self-learning algorithms have learned not to compete against one another.
And researchers in Italy have already found evidence of that happening in a simulated environment.
So they considered a very standard economic model of a market, one that's been used by many economists, both for theoretical and empirical work. And the question is, would they be able to learn to collude in a fairly kind of sophisticated and complex simulated environment? And the answer is very clearly yes. There were found to be prices that were just routinely well above competitive prices, sometimes quite close to monopoly prices.
He says these self-learning algorithms behave in a way that mirrors human cartels.
Algorithms are setting a high price above competitive prices, which creates then an incentive, at least in the short run, to set a lower price in order to pick up more market share and higher profits. What the self-learning algorithms have learned about the consequences of deviating from that by setting a lower price is that the other self-learning algorithm has adopted a pricing algorithm that will punish that behavior. So specifically, if one of them was to all of a sudden drop the price, the other self-learning algorithm's pricing algorithm was trained to respond with a very low price in response. The prices would remain low for some time, but they would tend to work their way back up to the high collusive prices. So what we have here really is these self-learning algorithms learning that, okay, we're going to set a high price. And the reason why they don't veer from that is they've learned that there's going to be a retaliatory punishment by the other self-learning algorithm. And that's exactly what we think about as collusion.
It's still an open question as to whether this kind of thing could happen in a real market with all its additional complexity. But the concept of automated collusion raises all sorts of legal questions.
If we go back to the example of on the Amazon marketplace and the online poster sellers, that's that type of collusion for which the legal framework is well designed. It's designed for conspiracy, where competitors communicate and coordinate their conduct. The law is defined in terms of a meeting of minds, a conscious commitment to a common scheme, the idea that there's been this communication which has led to some mutual understanding among competitors to no longer compete. All that is absent with competitors having adopted self-learning algorithms, as long as they did so independently. These self-learning algorithms don't have understanding, much less mutual understanding, which is really what's required in the context of the law.
And for now, there's no one in charge of monitoring if these systems are playing by rules we deem fair.
I mean, I think what really is the potential legal response in the future would be to prohibit certain properties of pricing algorithms. If those were prohibited, there'd be an incentive for the firms themselves to monitor their pricing algorithms, not to expose themselves illegally. But as right now, there really is no one monitoring them, and certainly the firms have no incentive, I would say, to monitor them.
He says anti-competitive pricing algorithms could also come embedded in software, which might be used by companies competing against each other without those companies even realizing it.
And then the question is, well, what can be done about it? And now here we're once again in a little bit murky legal territory because conspiracy requires two or more actors, which is traditionally two or more competitors who have decided no longer to compete. But now we're imagining that it's kind of one actor, which is a third-party developer, who might design a pricing algorithm that is not very competitive, and if it can convince many firms in a market to adopt it, will perform well for those firms because it will result in higher prices and less price competition. Now, once again, that's bad, but there's not conspiracy because there's really just that one actor, the third-party developer, who's promoting this.
And there is an example of that in the real world, in a study done of German gas stations that began adopting a pricing algorithm.
And the evidence is that average price cost margins did go up in response to this on the order about 12%. But what was really very striking was if you looked at markets where there were just two stations. So just imagine a geographic markets where there are just kind of two stations competing. And what the study found was that if one of them adopted the pricing algorithm, there was really no noticeable effect on prices. But if both adopted, then there was a significant increase in price cost margins on the order of around 29%. So now this is informative in terms of what these pricing algorithms are doing. If they're leading to just more efficient dynamic pricing, then you would have expected to see some effect even when just one station operator adopted it. But that's not what's found in the study. It's only when both competitors adopt it do you see an effect, and it's an effect which is a sizable increase in price. So I think that's something which is happening, and it's something a bit more, I think, concrete, and where there's potentially more policy options for dealing with, as opposed to the case of self-learning algorithms, which I think is a potential problem that we want to get ahead of.
We used to be able to change prices every days or every month, but now prices can change every hour, or in some applications, even every minute. My name is Maxime Cohen. I'm the Scale AI Chair Professor at McGill University in Montreal, Canada, and I'm also the co-director of the Retail Innovation Lab.
The past few years have seen an explosion of dynamic pricing practices, and personalized pricing is also increasingly common. In the future, dynamic pricing systems could be fully autonomous and applied at even larger scale, which begs the question, how do we protect our privacy when our data is being used to determine how much we pay for things?
So the pricing algorithm at the end of the day should be based on non-personal attributes. For example, you can collect purchasing history, you can collect potentially the location of the users, the actions they took in the past, but you don't want to use any type of personal attributes like names or gender or anything that is more personal.
Another question, where do we draw the line between fair and unfair pricing?
One needs to ask themselves the question, is it fair to offer different prices to different customers for the same products or the same service? And the answer to that question is not simple, actually. These two topics of privacy and fairness are very delicate and, in my opinion, need careful regulations moving forward.
He says regulators should come together and make clear what data can be collected, stored, and used to make pricing decisions.
For example, if Uber starts charging different prices based on a % of battery you have in your phone when you order a ride, would that be okay? Would that be not okay? So regulators should come together to the table and make a list of attributes that are reasonable to use for pricing decision and some other attributes in a blacklist where they should not be used for pricing decisions.
And it's not just our online shopping carts at stake. Dynamic pricing algorithms could soon find a home in physical retail as well, in the form of electronic shelf labels.
You can actually change the price of specific products at specific times by simply modifying a single line of code and pressing one button. You change one line of code and you can deploy a change of price at virtually zero cost. Now, the only remaining question in physical retail is how customers will react to such dynamic pricing practices. If you think about it, prices will start going up in supermarkets during busy hours. If there is a time of the day where there are a lot of people in the supermarket, prices will go up. Similarly, prices will start going up when you have very low inventory for specific products. If you have less stock, prices will go up in order to make sure that you optimize your profits. Now, it's not clear whether customers will be happy and they will be accepting those type of practices that are already in place in the online world. It may be definitely profitable in the short run, but it may generate long-run losses, especially in terms of customer loyalty. So we need to do a lot of research to try to understand the power and the potential benefits of dynamic pricing for physical retail.
This episode was reported by Anthony Green and produced by the two of us with Emma Silikans. We're edited by Matt Honan, and our mix engineer is Garrett Lang, with sound design and music by Jacob Gorski. Thanks for listening. I'm Jennifer Strong.
This is MIT Technology Review.